Suppose you work at Acme Manufacturing. Remember Acme Manufacturing, those of you that are familiar with the Roadrunner and Wile E. Coyote cartoons? Acme Manufacturing is Wile E. Coyote's favorite manufacturing company. Acme Manufacturing provides Wile E. Coyote with all of those tools that he tries to use to catch the Roadrunner. So let's suppose you work in the anvil production department. You know, Wile E. Coyote's always trying to drop an anvil on the Roadrunner, which I've always kind of wondered, there wouldn't be much left of the Roadrunner for him to eat if indeed he had ever been successful in dropping the anvil on the Roadrunner. But let's suppose that you're working there in the anvil department. And to make an anvil, it costs $35. And just to have your plant operating, producing anvils, there is a cost associated with that, a cost of $2,500 per day. Well, we can produce a linear equation in two variables, or a linear function if we want to use that terminology. We can produce a linear function that we could call a cost function that relates the daily cost to the number of anvils that we're going to make. And so the daily cost, will represent that by the letter C. And the C is going to depend upon the number of anvils we make. So let's let X represent the number of anvils. So this is a function that depends upon X. And it seems kind of logical. If X is the number of anvils you're going to make, then isn't 35 times X the dollars you have involved in making those anvils? $35 per anvil, X number of anvils being made. 35X would be the cost of making those anvils. But it also costs us $2,500 a day just to operate our plant. And so that produces this, what we could call cost function, a linear cost function. Remember, C of X is just another way of saying Y. So we've really just created a linear equation in two variables, but we're using the special function notation, C of X. So the cost for production for the day depends upon how many anvils we make times $35 per anvil plus $2,500 daily costs. In the business world, this $35 would be what we refer to as the unit cost. And the $2,500 would be referred to as what we call the fixed cost. It's fixed at $2,500 a day, no matter how many anvils we make. So this gives us a cost function, a cost equation that we can use. And the way we use these cost equations is to answer questions like, let's suppose tomorrow's production is supposed to be 80 anvils. Check my figures, see if that's the value I used. Yes. Let's suppose we're supposed to make 80 anvils. What would be the cost? Well, we're wanting to know what is the cost value, what's the Y value, when X is given a value of 80. And so we simply substitute 80 for X, and now we can perform that arithmetic. And if I take my handy-dandy calculator here, and I take 35 times 80 plus 2,500, I get a cost of $5,300. So to make 80 anvils will cost us $5,300. That's a point. That's the point 80, 5,300, isn't it? Isn't that how we always find points on the line This would be an equation that would have a straight line associated with it. It's a linear function, a linear equation in two variables. It would have a straight line associated with it. This would be the slope of the line, and in this case the slope is meaningful. It's $35 per anvil, and that makes sense because remember what slope is? Change of y over change of x. The y is the cost, the x is the number of anvils, so that's cost per anvil is the meaning of the slope. So it's $35 per anvil, and here's a point on that line. When x is 80, the function's value, the y value, the cost value is 5,300. So linear functions have some practical applications.